In the part 2 of our solution for the mock test 6 question paper, let us consider the question number 26 at first. In question number 26, it is a question from surface tension. The exists a soap film of a rectangular frame of wire of area 4 by 4 centimeter square. If the area of the soap film is increased to 4 into 5 centimeter square, the work done in the process will be. Here we are to find the work done in the process. The area of the film being 4 by 4 centimeter square to 4 by 5 centimeter square. The work done in the process, we know that work done equals to change in surface area into surface tension. And all the options are given in joule unit, that is in SI unit. And soap film, all we know, have two surfaces. So the change in surface area is double the change. Here surface area was 4 by 4 16 centimeter square, and now it is 20 centimeter square. So the change in surface area is 20 minus 16, and we have to convert it to meter square, that is we have to multiply it by 10 to the power minus 4. Then we will get the change in surface area. Now we require the total work done into surface tension. We have to multiply this factor into by surface tension. Now it is 4 into 2 8, 8 into 3 24, 24 into 10 to the power minus 6 joule. So B is the correct option. So the correct answer to the question number 26 is B. Now let us take the next question, that is the question number 27. In question number 27, we see that how many gram of ice at minus 14 degrees centigrade is needed to cool 200 gram of water from 25 degrees centigrade to 10 degrees centigrade. It is given that specific heat of ice is 0.5 calorie per gram per degree centigrade, and latent heat of fusion of ice is 80 calorie per gram. So we need m gram of ice. So ice will take first of all from temperature minus 14 degrees centigrade to 0 degrees centigrade, and it is a sensible heat. Next it will melt and it will take latent heat L per gram of ice. So that heat taken m into specific heat of ice 0.5, and temperature being increased from minus 14 to 0 degrees centigrade, that is 14 degrees centigrade, plus latent heat m into 80 equals to, and then the temperature goes to finally 10 degrees centigrade. So when ice melts into water, its temperature is 0 degrees centigrade, but the final temperature is 10 degrees centigrade. So this m gram of water coming from that melted ice will convert to water of 10 degrees centigrade. It will take sensible heat, and the amount of sensible heat is m into specific heat of water is 1 into 10 equals to needed to cool 200 gram of water from 25 degrees centigrade to 10 degrees centigrade. So heat energy released by water is 200 gram into specific heat 1 into temperature changes 25 degrees centigrade to 10 degrees centigrade, that is 15 degrees centigrade. So let us make the calculation at first. Here 14 into 0.5 equals to 7, 87, 97. So m into 97 equals to 200 into 15, that is 3000. So m equals to 3000 by 97, that is nearly just greater than 30, you may take it as 31 as per option is concerned. So it is nearly 31. So our correct option to the question number 27 is C. Now let us take the question number 28. In question number 28, we see that the absolute temperature of a body A is 4 times that of body B. So temperature of A, TA, equals to 4 into TB. The difference in wavelengths at their energy radiated is maximum is 3 micrometer. Difference in energy radiated, we know that from Wien's displacement law, lambda A into TA equals to constant equals to lambda B into TB. Here TA is greater than TB, so lambda B is greater than lambda A. Lambda B is greater than lambda A, and lambda B equals to lambda A into TA by TB. Now TA by TB is 4, so lambda B equals to 4 lambda A. Now the difference is 3 micrometer. So lambda B minus lambda A equals to 3, but lambda B equals to 4 lambda A. So 3 lambda A equals to 3. অতএব lambda A equals to 1. Then lambda B is 4. The wavelength at which the body B radiates, so lambda B is 4 micrometer. So our correct option to this question is C. So the correct answer of the question 28 is C. Now and let us consider the question number 29. In question number 29, it is a question from Newton's law of cooling. A hot liquid kept in a beaker cools from 80 degrees centigrade to 70 degrees centigrade in 2 minutes. We have taken m gram of liquid and its specific heat is S. Its temperature goes down from 80 to 70 degrees centigrade, that is 10 degrees centigrade. So the heat radiated is MST and the rate of heat radiated by 2. It is taken in per minute unit equals to K into average temperature. Average temperature of 80 degrees centigrade and 70 degrees centigrade is 75 minus surroundings temperature 30. In the second case, then the time of cooling of the same liquid from 60 degrees centigrade to 50 degrees centigrade. Then in this case, M is the mass of the liquid, S being its specific heat, and temperature goes down by 10 degrees centigrade. So here sensible heat is Ms into 10, time taken be T second, equals to K into average temperature is 55 and surroundings temperature is 30. So dividing equation 1 by equation 2, we get T by 2 equals to 75 minus 30 is 45. 55 minus 30 is 25. So T equals to 90 by 25 minutes. That is your 18 by 5 minutes. That is your 18 by 5 into 60 second. 512, 18 into 12, 216 second. We find it in option D. So our correct choice to the question number 29 is D. Let us take the question number 30. In question number 30, we see that 4 point masses, each of value m, are placed at the corners of a square ABCD of side L. We have a square of side L. 4 point masses are situated at the 4 corners of the square. ABCD is the square, 4 masses, M are situated at the 4 corners. The moment of inertia of the system about an axis through A and parallel to BD. This is BD, so we have to calculate the axis about the axis XY, the moment of inertia of the system. As mass at A is on the axis, so its moment of inertia is 0. And the diagonal length is L root 2. So the moment of inertia of the mass C is m into L root 2 whole square. Whereas the distance of the axis from mass D or B is half the diagonal length, that is your L root 2 by 2, that is L by root 2. So for mass B and D, the moment of inertia is m into L by root 2 whole square. And for the two cases, for B and D, total moment of inertia is twice of this value. That is ml square into 2 plus ml square by 2 into 2 being cancelled out, we get it 3 ml square. So our correct answer is 3 ml square. D is the correct option. So the correct choice of the question number 30 is D. Now let us take the question number 31. It is a question from gravitation. A body weighs 72 Newton on the surface of Earth. So the weight of the body is 72 Newton. That is your mg. If m be the mass of the body, it is 72. And g equals to gm by r square, where m is the mass of the Earth and r being its radius, and g is universal constant, universal gravitational constant. In the second case, the gravitational force on it due to Earth at a height equal to half the radius of the Earth. Now, g will change as gh equals to g by 1 plus h by r whole square. Now, h is half the radius of the Earth, h equals to r by 2. So, this is g by 1 plus. If h is replaced by r by 2, here we will get half whole square. 3 by 2 whole square, that is 4g by 9. So now the weight is mgh equals to m into 4 by 9 into g. Here mg is 72. So 4 by 9 into mg is 72. So mgh is 32 Newton. We find it in option D. So our correct choice of the question number 31 is D. Now let us take the question number 32. In question number 32, we see that a body is projected up with a velocity 3/4 of the escape velocity from the surface of the Earth. The height it reached. So from the Earth's surface it is thrown. Here the total mechanical energy is conserved. On the Earth's surface, the potential energy of the body is minus gmm by r, and it is thrown with 3/4 the escape velocity. So the corresponding kinetic energy is m into 3/4 into root over 2 gm by r, its whole square, equals to, when it is at a height h from the surface of the Earth, let it be h height, then its energy will be totally potential, and that should be minus gmm by r plus h. Now, minus gmm by r plus half m into 9 by 16 into 2 gm by r equals to minus gmm by r plus h. 2 being cancelled out, we get minus gmm by r plus gmm by 16 by 9 r equals to minus gmm by r plus h. It should be 9 by 16. Now 9 by 16 minus 1 minus 7 by 16. This is minus 7 by 16 gmm by r equals to minus gmm by r plus h. And the left hand side may be written as gmm by, left hand side may be written as, it is as minus 16 by 7. And this should be written as r plus 9r by 7, 9r by 7, that is minus 7 gmm by 16r equals to minus gmm by r plus h. Comparing both sides, we get h equals to 9r by 7. So h equals to 9r by 7. So the correct choice to the question number 32 is B. So question number 32 having correct choice B. Now let us see the question number 33. In this question, we see that three identical bodies of mass m are located at the vertices of an equilateral triangle of side L. They revolve under the effect of mutual gravitational force in a circular orbit, circumscribing the triangle while preserving the equilateral triangle, the orbital velocities. Now, we are taking an equilateral triangle, three masses are circulating through the circumference circle, and let the force on each mass on a mass by other masses be F, and this F is actually gm square by L square, and angle in between them is 60 degree. When two forces are F and angle is 60 degree, we know that the resultant force is root 3F. That is, your resultant force is root 3 into gm square by L square. So resultant force is gm square by L square, and it is actually giving the centripetal force of the mass, m into v square by r. What is r? Height is root 3L by 2, and it is 2/3 of that. Center of gravity having distance 2/3 of the height. That is your L by root 3. So mv square, then this is mv square by L by root 3 equals root 3 gm square by L square. Root 3 into mv square by L equals to root 3 into gm square by L square. Root 3 being cancel out, m being cancel out, v equals to root over gm by L. So v equals to root over gm by L. 33, question number 33 having correct option A. Now let us take the question number 34. A body is projected with a velocity 2 into 10 to the 11.2 kilometer per second from the surface of the earth. So the velocity is twice the escape velocity. The velocity of the body when it escapes from gravitational pull is. So velocity is twice the escape velocity. Kinetic energy is 4 times. When it goes out of the Earth's atmosphere, then just 1 part of kinetic energy is lost. So 3 part of kinetic energy will be there. So the speed will be root 3 times v. So now the speed is root 3 into 11.2 kilometer per second. So correct choice of the question number 34 is A. Now let us take the question number 35. In question number 35, we see that two satellites A and B go around a planet P in circular orbits having radii 4 and r respectively. If the speed of the satellite A is 3b, the speed of the satellite B is. So you have to calculate the speed of the satellite now. Speed of the satellite, we know that the centripetal force mv square by r equals to gmm by r square. So v equals to root over gm by r. So v is proportional to 1 by root r. In the first case, velocity a is 3v when the radius of the orbit is 4r. So 3v equals to root over gm by 4r. In the second case, radius is r, so vb equals to root over gm by r. So 3v by vb equals to half. So vb equals to 6v. So b is the correct answer. Correct answer to the question number 35 is B. Now let us take the question number 36. On a frictionless surface, a block of mass m moving at a speed v collides elastically with another block of same mass m which is initially at rest. After collision, the first block moves at an angle theta with its initial direction and has a speed v by 3. The second block speed after collision collides elastically. When the collision is elastic, the kinetic energy conservation law is valid. And In a frictionless surface, a block of mass m moving with speed v, so its kinetic energy is half mv square. With collides elastically with another block of same mass which is initially at rest, so the inner kinetic energy of the second mass initially is 0. After collision, the first block moves at an angle theta with initial direction and having speed v by 3, so its kinetic energy is half m into v by 3 whole square. For the second block, it is half mass is m into v1 square. So we get that. Taking half m cancel. So v square equals to v square by 9 plus v1 square. So v1 square equals to v square minus v square by 9, 8 v square by 9. So v1 equals to 2 root 2 v by 3. So our correct choice is C. So for elastic collision, if we want to express one velocity in terms of other, and if one of them were initially rest, then like this problem, when the speed of the first mass is given in terms of its initial speed, then only one quantity, that is v1, was unknown. So only one equation was needed to calculate v1 in terms of v. In this case, it is easier to apply kinetic energy conservation law, because kinetic energy is a scalar quantity, so we are not to consider the direction of motion here. So it will give easy solution to the problem. For question number, now we will consider the question number 37. In question number 37, we see that a rope of mass, negligible mass, is wound around a hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with a force 30 Newton? So a rope is wound over a hollow cylinder and the rope is pulled with 30 Newton force. 30 Newton force. Assume that there is no slipping. So when it is pulled with 30 Newton and radius is 40 centimeter, then torque applied 30 into 40 into 10 to the power minus 2 Newton meter equals to I alpha. What is the angular acceleration? We need angular acceleration alpha, and for a hollow cylinder it is mr square. Mass is 3 kg, so m is 3 kg, r is 40 into 10 to the power minus 2 whole square into alpha, mr square into alpha. So alpha equals to what? 40 into 10 to the power minus 2 being cancelled out. Alpha equals to 30 by 3 into 40 into 10 to the power minus 2. That is actually 30 into 100 by 3 into 40. 3, 10, 4. 100 by 4 equals to 25. So the answer is 25 radian per second square. 25 radian per second square. So the correct answer of the question number 37 is D. Now let us consider the question number 38. The system is released. Here is a pulley problem. There are two masses, m and 3m are hanging from both the parts, and now we have to calculate the acceleration of center of mass of the system. Now the acceleration of the system is actually, here the downward pull is 3mg and here downward pull is mg. mg is actually acting against the direction of motion. So the acceleration of the system is 3mg minus mg by 3m plus m is 4m. So this is g by 2. Acceleration of the system is g by 2. Now ACM equals to m1a1 plus m2a2 by m1 plus m2. m1 is 3m, a2 is g by 2, m2 is m, But here the motion is actually acceleration in the upward direction. Downward acceleration is taken as positive, so A2 is minus g by 2. Then m1 plus m2 is also 4m. So 3mg by 2 minus mg by 2, that is mg by 4m, that is your g by 4. So the acceleration is g by 4. Correct choice is A. So the correct choice to the question number 38 is A. Now let us take the question number 39. In question number 39, we see that two bodies of masses 2 kg and 4 kg initially at rest are moving with velocities 2 meters per second and 10 meters per second towards each other due to mutual gravitational attraction. What is the velocity of their center of mass now? Initially, bodies were at rest. So, the velocity of the center of mass VCM equals to m1 v1 plus m2 v2 by m1 plus m2. As v1 and v2 equals to 0, so VCM equals to 0. Now the bodies are moving towards each other due to the force, gravitational force of attraction. Gravitational force is a mutual attractive force, action-reaction force, and when only action-reaction force is acting, we know that there is no change in the velocity of CM, center of mass having no acceleration there. So it will move with unchanged velocity. So now also the velocity of the center of mass is 0. In absence of any external force, there is no acceleration of the center of mass. Initial velocity of the center of mass was 0, as there is no acceleration, so the final velocity of the center of mass is also 0. So the correct choice of the question number 39 is C. Now let us see the question number 40. From a circular ring of mass m and radius r, an arc corresponding to a 90-degree sector is removed. Here is a ring. It has 4 sectors. One sector is removed. Just like this, now the shape of the ring. So 1/4 of the ring is removed. So if earlier the mass of the ring was m, now it is 3m by 4. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring and perpendicular to the plane of the ring is k times mr square. Then the value of k. Originally, the moment of inertia I of the ring is mr square. Now, mass distribution is same, so the formula is same. So moment of inertia formula is m into r square, but here m is 3m by 4 because 1/4 portion has been removed from here. So the mass of the ring is actually 3m by 4. So moment of inertia is 3m by 4 into r square equals to mk square, equals to mk square. mk square. So k is equals to k square is actually the value of ring is k times mr square. Sorry, this is k times k into mr square. So simple calculation actually gives k equals to 3/4. So k equals to 3 by 4. K equals to 3 by 4. Correct choice is A. Correct choice to the question number 40 is A. Now let us consider the next question, that is our question number 41. In question number 41, we see that a wheel of moment of inertia 2.5 kg meter square has an initial angular velocity 40 radian per second, omega 1 equals to 40 rad per second. A constant torque tau of 10 Newton meter acts on the wheel. The time during which wheel is accelerated to 60 radian per second. Final angular velocity is 60 radian per second. We have to calculate the time taken. When torque is applied, there should be an angular acceleration, and tau equals to I into alpha, where alpha is the angular acceleration. Here tau is 10 and moment of inertia is 2.5, actually 2.5 into alpha. So alpha equals to 10 over 2.5 means 4 radian per second square. Again alpha equals to omega 2 minus omega 1 by t. So 4 equals to 60 minus 40 by t. So t equals to 20 by 4 equals to 5 seconds. So our correct choice is C. So the correct choice to the question number 41 is C. Now let us take the question number 42. A rotating body has angular momentum L. That is, our L equals to I omega. If its frequency is double, kinetic energy is halved. Now kinetic energy, rotational kinetic energy is half I omega square. If omega becomes twice omega, so kinetic energy should be 4 times, but kinetic energy is halved. So I dashed equals to I by 8 actually, because if omega were twice, its value should be 4 times, this factor giving 4 times. So I should be I by 8, that will give actually kinetic energy to a half value. That will convert the kinetic energy to its half value, half of the initial value. So now angular momentum L equals to I. Now I is I by 8, omega is twice omega, I omega is L, so it is L by 4. Now angular momentum L dash is L by 4. So correct choice is D. Correct choice to the question number 42 is D. Now we will go to the question number 43. In question number 43, force F on a particle moving in a straight line varies with distance as shown in figure. The work done on the particle during the displacement 12 meter. Here is a force displacement curve, and the area of the force and displacement curve area equals to work done. Now from 0 to 3 meter there is no force acting, so the work done is 0. From 3 to 12 we see here is a trapezium. Having the area of the trapezium will give you the total work done. The parallel arms of the trapezium being 3 to 7 means 4 unit, and another is 3 to 12, that is 9 unit. So area equals to half into 4 plus 9 into perpendicular distance in between them. That is your 4. That is your half into perpendicular distance in between them. So we may consider it is as this. Here is a you have a rectangle having side 2 unit, having side 2 unit, 2 unit, and here is 4 unit. So 2 into 4, 2 into 4, that is 8 unit, plus area of the triangle half into base is 2 unit, and this is 7 to 12, 5 unit, it is 5, 8 plus 5, that is 13 joule. So the answer is 13 joule. So correct answer to the question number 43 is D. Now let us take the question number 44. Two spheres A and B of masses m1 and m2 respectively collide. A is at rest initially and B is moving with velocity v along x-axis. B is moving with velocity v along x-axis. After collision, B has a velocity v by 2 in a direction perpendicular to the original direction. So B having initial momentum m2v, now the momentum is m2 into v by 2 but in the y direction. A was at rest, it has no momentum. Now according to momentum conservation law, there was no momentum along y-axis, so A will acquire a momentum in this direction, in the negative y direction. If it were y direction, in the negative y direction is m2 into v by 2, and it will get also the initial whole momentum of B. So the momentum of A will be the resultant of m2v, that is along x-axis, and m2 into v by 2 for the adjustment of the final momentum of v, it will acquire also this momentum. So the final momentum of A will be the resultant of these two vectors. And if we consider the angle theta with the x-axis, then tan theta equals to m2 into v by 2 whole divided by m2v. So tan theta equals to half. So theta equals to tan inverse half to the x-axis. So C is the correct answer. So the correct choice of the question number 44 is C. Now let us take the last question. That is the question number 45. A block of mass 10 kg moving in a direction with a constant speed 10 meter per second is subjected to a retarding force 0.1 x joule per meter during its travel from x equals to 20 to 30 meter. Its kinetic energy, final kinetic energy. Now the question is, what is the initial kinetic energy? So initial kinetic energy is half mv squared equals to half a mass is 10 kg, v is 10 meter per second, that is half into 10 into 10 square, that is 1000 by 2, 500 joule. It was the initial kinetic energy. Now to calculate the final kinetic energy, we have to consider why the kinetic energy is changing. Actually, retarding force is acting on the system, on the body, and the work done against the retarding force equals to change in kinetic energy. Retarding force F is proportional to x. So the work done against this force is average force F by 2 into x. That is your 0.1 into x. F is 0.1 into x and into x by 2, 0.1 into x square by 2. So 0.1 by 2 x square, that is x being changed from 20 to 30. So x2 square minus xn square gives 30 square minus 20 square. 900 minus 400, 500 into 0.1, 50 by 2, 25 joule. So the work done against the retarding force is 25 joule when the body is displaced from 20 meter to 30 meter. Initial kinetic energy was 500 joules, so there is a reduction of kinetic energy, that is 25 joule. Now the final kinetic energy is 500 joule minus 25 joule, that is your 475 joule. Correct option is C. Correct option to the question number 45 is C. So that is the end of our descriptive type discussion of the answers. Now we will take the MCQ type description, MCQ type answer at a glance. First question, MCQ type answer of the first question. One was B, 2 for the question number 2 it was C, for 3 it was A, 3A, 4A, 5B, 6C, 7B, 8C. There was a mistake. We have find the answer v equals to 2 meter per second in question number 8, but we marked it as A, but the actual answer is C. So the answer of the question number 8 is C. Next, 9B, 10D, 11B, 12B, 13A, 14A, 15C, 16B, 17A, 18A, 19B, 20D, 21B, 22B, 23C, 24A, 25A, 26B, 27C, 28C, 29D, 30D, 31D, 32B, 33A, 34A, 35B, 36C, 37D, 38A, 39C, 40A, 41C, 42D, 43D, 44C and 45C. Our next mock test is mock test 7. Topic of that mock test are statics and rigid dynamics, gravitation, statical electricity, current electricity, up to the instrument, that is up to potentiometer, kinematics and SHM. And the probable date of that exam is 19th June 2022. And that's all from this lesson. Good night to you all.